And welcome back. Okay, so this is the second video on mole calculations, and hopefully by the end of this video you should be able to write equations linking volume, molar volume and number of moles, and be able to answer questions requiring you to calculate volume of gases. So in the previous video we came across a calculation triangle that looked like this. Now we're going to look at a similar one in this video. I just need to make a couple of changes, because in this video, instead of looking at mass, we are going to look at volume, and instead of using the molar mass, we are going to use the molar volume. Okay, so you can see these two triangles are very similar. Number of moles is in the same place, and in one of them we have mass, whereas the other we have volume in the same place. And in the final part, instead of having molar mass, we have molar volume. So all quite similar. Now, what is the molar volume? I can hear you saying. Well, Avogadro, the same guy who came up with the constant, he postulated that 1 mole of any gas will take up the same volume. If you think about the structure of a gas, how much space is in between the particles, it makes sense. If the particles are slightly bigger or smaller than each other, it doesn't matter, because there's so much space that a slight change in size of the particle won't affect the overall volume. So 1 mole of gas has a volume 24 decimeters cubed per mole, which is the same as 24,000 centimeters per mole. Now you'll notice I didn't put any units in the triangle. That's because if your volume is in centimeters cubed, you can use the molar volume in centimeters cubed. If it's in decimeters cubed, you can use the molar volume, which is in decimeters cubed. Okay, so it just depends on your question. So we went through in the last video how to use one of these triangles to get the different equations for the 3 different variables. I won't go through it again, but I'll quickly write down the 3 equations you can get from this triangle. So here's the 3 equations, which I derived just the same way as before, covering the one variable you're after and just writing down the other 2 and the relationship between them. So in the previous video we went through a sort of cycle of how to convert between mass of one chemical and a mass of another in the same equation. Now we have to be able to do similar things with the volume. So let's just have a look at 2 examples. Now in the first example we're going to have a look at how to go from a volume of one gas to the volume of another. So just like last time, step 1, write out the equation. Step 2, balance it. I've already done that for you. Step 3 is to highlight the chemicals from the question. So calculate the volume of oxygen, that's what we are after. And we are given information about methane, which is here. Okay, so next, write down the information that you have. So we have 123 centimeters cubed of methane. So next step is to work out moles of methane, and we use the triangle we've just looked at to be able to do that. So again, I'm going to just quickly draw that triangle so that you have it in front of you. So hopefully you can see that to go 2 moles of methane, you have to do the volume divided by the molar volume. Now in the question, the volume was given in centimeters cubed, therefore we continue to use centimeters cubed. So in this example it's 123 centimeters cubed divided by 24,000. And this gives us our moles of methane. So stick that in your calculator, which gives you 5.125 times 10 to minus 3 moles of methane. Next step is to work out moles of oxygen. And hopefully you can remember how to do this. You just use the molar ratio, which in this case is 1 to 2. So we divide by 1, then multiply by 2. Obviously, this is just multiplying by 2. This gives us 1.025 times 10 to the minus 2 moles of oxygen. And then the final step is just to work out the volume of oxygen. Go back to your triangle. You are now looking for volume. So we need to times our number of moles. 1.025 times 10 to the minus 2. And you multiply it by the molar volume, remembering to use the version of the molar volume with the same units. So in this case, 24,000, which gives us 246 centimeters cubed of oxygen. Now, hopefully you are looking at the volume we started with and the volume we ended up with, and you are seeing a pattern. Because the molar volume of a gas is the same for every gas, you don't really need to do the whole cycle for this type of problem. We had a 1 to 2 ratio between the number of moles of methane and oxygen. Therefore, the volume you started with the methane, all you had to do was multiply that by 2. Okay, so because the molar volumes are the same for any gas, the ratio of volume will just be the same as the ratio of moles. So that's a bit of a trick for this specific type of problem. However, with this next type of problem, you will need to use the triangles. So first of all, I'm just going to draw the 2 triangles we've covered so far. Apologies for the very wonky triangles. Okay, so let's have a look at this problem. Calculate the volume of carbon dioxide, so calculating volume again, produced when 2.68 grams of calcium carbonate is heated and decomposes. So this time we are starting with a mass and we have to find volume. So in this type of problem, we have to use both triangles. Okay, but it's a very similar process as to what we've already seen. So let's just get straight on with it. Now, like always, the first 2 steps are to write the equation and to balance it. Third step is to highlight the chemicals we are looking at in the equation. So first of all, we have carbon dioxide, which is over here. And we also have information about calcium carbonate. So we have 2.68 grams of calcium carbonate. Next step after this is always to find number of moles. Moles of calcium carbonate. Now we are starting with a mass, so we need to use this triangle over here. We do this by dividing the mass by the molar mass. Now in this case, they don't give it to you in the question, but you can just work it out using the periodic table which will be provided in your exam. And it comes out at 100.1 grams per mole. So just put this into your calculator, which comes out as 2.678 times 10 to the minus 2. But just remember to keep the actual full value in your calculator. Try not to round and then use the rounded version in the next step. Okay, so the next step is to find the moles of carbon dioxide. Remember, we do this by using the molar ratio, which in this case is 1 to 1. So we don't actually need to do any sort of sum with this because it just has the same amount of moles. So final step. Now, in this case, we're going to the volume of carbon dioxide. So we need to use the second triangle. We have the moles, we want the volume. So you cover volume, so it's the number of moles, multiplied by the molar volume. Molar volume is 24,000 centimeters cubed. So put that into your calculator, which comes out at 642.6 centimeters cubed. And that is our final answer, because we were asked to find the volume of carbon dioxide. So even though we needed to use the two different types of triangle, hopefully you can see it's a very, very similar process. And everything we've looked at so far, you write down the information you have, you work out the moles of the chemical you have, you then use molar ratio to work out the moles of the chemical you want, and then you just find out either the mass or the volume. It's the same process. So hopefully you can now write down the equations linking volume, molar volume, and the number of moles using the calculation triangle we looked at. And you should be able to answer a range of questions. We looked at two different types of question, and hopefully you will have no problems in working out volumes in either of those scenarios. Make sure you've completed your notes. I'll see you in class.